Okay, I'm going to continue on with some examples of logarithmic differentiation to finish up this series of videos. And I have this problem, y equals theta sine theta over the square root of secant theta. And again, you could do the quotient rule, and inside the quotient rule you'd have the product rule, but we're going to do logarithmic differentiation. The one thing I want you to notice is I'm going to write secant theta as this way, raised to the half power when the time comes. And we're going to natural log both sides. So if I natural log this side and natural log this side, because that's what we do with logarithmic differentiation, I'm going to have the natural log of y equals the natural log of theta, because it's multiplied, plus the natural log of sine theta, minus, and I'm going to bring the 1/2 right down now, 1/2 the natural log of secant theta. So again, this has been expanded. We haven't done the derivative. Now we're going to actually do the derivative. So I'm going to do 1 over y, which is the derivative of the natural log of y, dy dx, equals 1 over theta. Actually, this should be dy d theta. I apologize for that. Dy d theta. So it's 1 over theta plus 1 over sine theta times the derivative of sine theta, which is cosine theta, minus 1/2 times the derivative of natural log, which is 1 over secant theta. Then we have to do the derivative of secant, which is secant theta tan theta. So this is kind of nice right here. See how these two kind of cancel out? So I'm going to cancel those right out right now. So there's the times here. So then I'm going to rewrite this a little bit nicer before we start solving for dy d theta. So if dy d theta equals 1 over theta plus cosine theta over sine theta minus tan theta all over 2. Okay? So what I'm going to do now is multiply both sides by y, because I want to solve for dy d theta. So dy d theta is going to equal y times 1 over theta plus, this we can change to cotan theta, minus, we'll do 1/2 tan theta. Tan theta over 2 would still work also. And we're going to replace, remember, the y with our original function, because y equals that. So this is going to equal theta sine theta over radical secant theta times 1 over theta plus cotan theta minus 1/2 tan theta. So there's our derivative right there. We found it. This whole thing is our derivative. Alright? Try a couple more. Okay, the 6th one. Now, I'm putting in here actual log ones, and I'm going to let you know that sometimes I take the derivative as it is, because you do have in your derivative card where you have the derivative of log with a different base. I typically try to use the change of base formula, which is, alright, so if I have the change of base formula, it is usually ln u over ln a. And in this case, the u would be the inside here. That's our change of base formula. And I use this a lot because I really like having everything in the natural log, because the derivative is so simple. So if I'm going to change the base, which is just changing how it is, this is the same as saying the natural log of 1 plus theta natural log of 3, okay, all over the natural log of 3. So all I did was change the base formula. Now I'm going to continue on, because if you will, ln 3 is a number, okay, and you have the natural log of that. So I'm actually going to make this kind of a coefficient and move it in the front. And when I do, I'd say 1 over the natural log of 3. So that is the actual number, or your coefficient, natural log of 1 plus theta natural log of 3. Okay, so I just kind of rewrote it and put the coefficient right in the front because then it makes it easier doing the derivative. Okay, now this one actually has a log in it, so we're not doing logarithmic differentiation, if you will, but we're taking the derivative of natural log, so it's just a different method. So now I have y prime, if you will, all right, or dy d theta. So the derivative, and I'm looking here, this is what I'm looking at to do the derivative. Well, it's going to be equals 1 over the natural log of theta, natural log of 3, because that is a constant. And the derivative of natural log is 1 over 1 plus theta, natural log of 3, times the derivative of the inside. And since theta is your x value, when I take the derivative of 1, it's 0. When I take the derivative of theta, natural log of 3, it's just plain old natural log of 3. And so I just took the derivative. And the cool thing here I can see is this and this can cancel. So that's nice. Thanks for playing. I appreciate that. So the derivative is y prime is 1 over 1 plus theta natural log of 3. So there is our derivative. Okay? Now if you use the derivative of log, okay, so I'm going to put a big or here. So the derivative of log, okay, that would be 1 over, so y prime would be, just to show you how this works, 1 over, and then it'd be the u, which is 1 plus theta natural log of 3, okay, 1 over u, and then you're going to do the times the natural log of 3, which is your base, okay, times the derivative of the inside, which is natural log of 3. So those would cancel right out, and I would end up with the same answer. Now, you say to me, all right, why, since this is basically one step using the log derivative, why are you doing change of base formula? Because if I'm going to memorize one, this is the one I'd want to use, and you just have to do a little bit of algebra, but they both work. You get the same answer for both. So if you want to use the log derivative, that's fine too. You'll get the answer both ways, okay? 7, I'm going to do both ways also. I'm going to do it with the change of base formula first, and then I'm going to do it the other way. So first of all, if I didn't do change of base formula, if I use the regular log derivative, you'll notice I'd have to do the product rule. So let's do change of base formula. So if I do this, log base 2 of r is ln r, okay, over ln 2. There's my change of base formula. Times, this would be ln r over ln 9. Again, I look at these as a number. I'm going to bring them kind of around front here. And so I have 1 over the natural log of 2, the natural log of 9, times, and this is natural log of r times natural log of r is the natural log of r squared. Okay, so I haven't done any derivative. I just changed the base and rewrote it a little bit. Okay. Now, I have y prime here. So if I take the derivative of this, and this is what I'm looking at for the derivative, is this right here. Okay. So if I take the derivative of that, it's going to be, ready, 1 over, because this is a constant, natural log of 2, the natural log of r. And the derivative of this is going to be the power rule first, 2 times the natural log of r raised to the first power times the derivative of the natural log of r, which is 1 over r, which equals 2 the natural log of r all over r natural log of 2 natural log of 9. So there is our answer, our derivative. Okay, so I'm going to show you the other way if I have enough room here. Let me see. Yeah, let's go back here. The other way doing this is a little bit more involved, but I'm going to fit it in here if I can. So we're going to use this right here. So the first thing is I'm going to go back to the original here, and I'm going to use log derivatives. So if I do that, this is my f and this is my g. Notice I didn't have to do this with this way, okay? So if I do that, f is going to be log base 2 of r. F prime is going to be 1 over r natural log of 2, because that's the derivative of log. G is log base 9 of r, so g prime is going to be 1 over r natural log of 9. Okay, so I've got to do my derivative. So I'm going to come over here and say y prime is f prime g, so I'm going to do log base 9 of r times 1 over r natural log of 2, f prime g, okay, plus f g prime, so I got log base 2 of r times 1 over r natural log of 9. Okay, so when I go through and multiply these through, okay, you're going to see that you can then start changing the base here, because now you got natural logs and logs mixed in together. So this is the same as saying the natural log of r over the natural log of 9 times 1 over r natural log of 2 plus the natural log of r over the natural log of 2. So I still use change base formula for here in this and here and here. So do you see why the other way is a little bit easier? And this is times 1 over r natural log of 9. Okay? Now, whoops, sorry. What am I going to do next is kind of factor out the natural log of r, because I can. So if I factor out the natural log of r out of here, I get, okay, 1 over r natural log of 9 natural log of 2 plus 1 over r natural log of 9 natural log of 2. And if I put those together, you end up with, okay, I have 2 of these here. This is the exact same thing. So I end up with 2 natural log of r's, okay, because this adds up to 2, all right, and you're multiplying, and the bottom is going to be r natural log of 9 natural log of 2, which is the same thing as what we had before. I personally like the change of base formula, but I just wanted to show you that you could do it the other way and get the same answer. So that sums this up.